lecture for those students who haven't. I'd like to ask your permission for those students to have this recorded because since there is a problem with internet connection now, so it's impossible for them to have the class online. Do you agree for the recording? Good afternoon.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, thank you. So we will start our lecture now. So I'm going to share my screen. So we will start with the routing technologies. Then after routing technologies, we'll have switching technologies. So what is routing and switching technology? So these are the detailed description of a router on how router works in handling data or packet of information. So now we are on lesson 6 and we almost going to finish all of this week, and also tomorrow we will be able to possibly discuss the two topics, and after that you have your online test and also your end term test. Now for lesson 6, so we have so many things to discuss. That's why I waited for your other classmate to have this opportunity to be in the class, but since the situation and there are problems with interconnection, so we'll have this recording for this lecture. And for this, we'll move forward on aside router. What is a router? Router allows you to connect to your ISP or your internet service provider, and it divides the network into several broadcast domain. And also in this lecture, it is used to make a complex internetwork so that the local area network can be operated in a large international corporation. So in this example, so we have several network. In each network, there is interconnection on each router. So for example, this is from another building, another department, and this connected into another department, and this one is connected to another department, and this one will be connected also to another department. So in such a way, they will have to communicate between router to router, or using their IP address or their specific gateway. So in order for you to connect to your ISP, so you have your gateway. And in such case, routers usually operate at network layer 3, and it's work with packets as what is PDU? Anybody? What is a PDU? So since you're working on layer 3, so you have your protocol data unit, and these advanced devices connect separate logical networks to form internetwork. A router can be used to facilitate exchanging data between networks, but broadcast frames are kept in their respective networks. So internet uses routers to interconnect to thousands of networks around the world. So this is your reference. And as of this period, we're going to talk about how routers process. So we have the following features that are usually found on routers. So first, we have router interfaces. The second, we have the routing tables, and the third would be routing protocols. And the last would be the access control list. So what are router interfaces? So uh, a router interface allows to receive frame. It forms data link layer, which comparing the destination of your physical address with the interface of MAC address. If they match, the router reads the frame and strip the frame header and trailer. So if they don't match, so the router discards the frame. The next router checks the resulting packet's destination IP address. So if this address matches the IP address, the interface on which the data was received, the packet was intended for the router. So we simply strip off the packet and check whether it has the match of the IP address. And in such case, the router knows the packet should be routed to another network. So after that, after the match making a packet, so it consults its routing table to determine how to get the packet to its destination and moves the packet from incoming interface to the interface that will get the packet to its destination, or we call it the outgoing interface. So the process of moving a packet from incoming interface to the outgoing interface is called packet forwarding, or just forwarding. So before the packet can be sent to the outgoing interface, however, it must be encapsulated in a form of a new frame header and trailer. So this frame header and trailer are your what? These are your, it's like synonymous to your letter, that you have your receiver address and your sender address. So the new frame header contains the outgoing interface physical address as the source and the MAC address as a destination. So that's why I told you. So you have sender and receiver. So next, we have to have the router tables. So routing tables are composed of mainly of network address and interface pairs that tell the router which interface packet should be forwarded to, so that it gets to its destination network, the destination network also, and the next hop and metric, and how the route is derived and the timestamp. So this is what I already performed last time in Pocket Tracer. So we discussed how the route is being uh, or the packet is being traced to each destination. And also we have how many time it's going to receive and send the data. So we have the sample of one of the protocol that is using routing tables, and we have this type of protocol. We have OSPF. So later we will discuss OSPF. So it, as you know, ingress. Have you what is ingress? So ingress is the input property. Uh, Egress is the output property, and ingress will allow us to say that So ingress allows us to input a property on a specific IP address. And after that, if it's going to be read by your data plane, so it's going to be forwarded to the output property. And as you know, we could be able to transfer the information using a routing table. And also, you have the data plane forwarding table for the data transfer of this specific property. So, router tables receive data from the control plane, and it was going to be forwarded by the Ospf topology and process. And the last part, the routing table allows you to check which one is going to be prioritized, and the next it would be forwarded to data plane, and the property would be inserted to the IP forwarding table. Then after that, when it reads the property, and it's going to be sent to the output property of the network. So as you know, we start with the routing protocol, OSPF. We have the slow path, your routing table, because in this side, you're going to check which is, it's like you're going to the post office. You have specific drawers where the mail is located, where can you find this address. So as you know, it's difficult to check. So that's why there will be a slow path. And after this, you will going to determine the address resolution protocol. So to tell the source and destination and the IP address. So that's how it's going to work in routing tables. Now, routing tables consist of a destination network as usually expressed in CEDAR notation. And when a router receives the packets on one of its interface, it compares the packet destination address with the list of destination networks in its routing table. If it is finds a match, the packet is forwarded as specified by the information in the next hop field. So this is the second step in your routing table. So the next hop, so it's your gateway. So it indicates the interface name of the address of the or the address of the next router in the path to destination. And after that, it's going to be identified by the physical address is retrieved. A frame is delivered if an address is specified. So the router retrieves a physical address of the next router and forwards the frame on its way. When a packet must be sent to the router to get to its destination, it's called a hop. So as you see in your example, we put a serial hop in your, I give you an example of a packet tracer file. So when you see a serial hop, you see a red connection, but it is usually connected from a different location. And the total number of routers a packet must travel through is called a hop count. So another step in your router table is your metric. So the numerical values tells how far away or the distance of the network. So in other terms, the metric are cost and distance. And usually, if the destination network is directly a metric, is usually zero. The values used to determine the metric depend on how the routes get onto the table. And we're going to discuss the next step. So after we determine the metric, so we now going to determine how the route is derived. So this field tells you how the route gets into the routing table, and the route is added to the routing table in three main ways. First, the destination network is connected directly. Second, the administrator enters the route information manually. We call it the static route. And or the last is we determine the route information entered, which is entered dynamically via routing protocol. And also we have the last part of your routing table. So we have the timestamp. This is just a switching table, which entries we need a timestamp. So to do routing table entries, but only those that are created dynamically. A timestamp tells the router how long it has been since the routing protocol updated the dynamic route. So not all routing protocols require timestamps. So that's why this one is optional. So most of the time we considered only until the how the route is derived. So we have five uh, routing tables method. So we are only consider the four as one of the important to determine the routing table. You should have the four, but this one is optional. It depends on the network. So now we move forward to the routing protocol or the static routes. So you might wonder whether your network should run a routing protocol at all. So routing protocol aren't necessary in all situations, as static routes can be entered in a routing table manually. So likewise, we are doing the static routing using the method that we have. So what we have is the routing table, like if you solve a network, so we going to write the list of static routes that we will have. So you have from one point to another point. So later we will try to open the packet tracer and to see if we have static routing performed. Actually, I have already sent you this file in your for your Cisco packet tracer. So later we will open it. And also we have the first routing protocol. So we have the open short past first. So this is a link state routing protocol that was developed for IP networks and is based on the short path first algorithm. So it is an interior gateway protocol. It was actually by IBM. So on the same way, OSPF network routers and system within the same maintain identical link state database that describes topology of the area. So each router or a system in the area generates a link state database from the link state advertisements. So we call it LSAs, and it receives from all other routers or system in the same area, and the LSAs that itself generates. An LSA is a packet that contains information about neighbors and path cost. So based on the link state database, so each router or system calculates a short path spanning tree with its itself as a route using the SPF algorithm. So you have the short path first algorithm. So So what are the advantages of using SPF, OSPF? So compared with distance vector routing protocols such as routing information protocol, OSPF is more suitable for serving large heterogeneous internetwork. OSPF can recalculate the routes in a short amount of time when the network topology changes. With OSPF, you can divide autonomous system into areas and keep area topologies separate to decrease the OSPF routing traffic and the size of the link state database of each area. Also, the last is OSPF provides equal cost multipath routing. You can add routes to the transmission control protocol stack using different net hubs. So these are the key advantages of using OSPF. And also, we have to discuss some of OSPF Hello Protocol and Link State Database Exchange. So in this way, after the routers or system in OSPF network ensure that their interfaces are functional, they first send out hello packets using hello protocol over their OSPF interface to discover neighbors. The neighbors are routers or systems that are interfaces to the common network. After that, neighboring routers or systems exchange their link state database to establish adjacencies. So the following figure illustrates the process of discovering neighbors and establishing adjacencies for two systems in 9.7.85.0 subnet. Each system has an OSPF interface to common subnet of 9.7.85.0. So this subnet can be seen to the next slide. So we are going to this one. So these are OSPF. We have system A, the router identifier 1.1.1.1. And we have the system B as router identifier 2.2.2.2. And the message sequence can be seen as hello. And after that, you're going to forward the information. So as you know, you have 9.7.85.0 subnet, and each system has a common subnet of this, and for system A and for system B. So this is system A and system B. So your common subnet is this one and this one. And the process of OSPF will start at the start, exchange, loading, and full. So meaning you have to have a link state update of the connection. So what are the phases in OSPF? So what do we mean by X-start phase? This is the first step of the link state database exchange. So two systems negotiate who is the master and who will be the subordinate. And it's like you are the leader and who will be the member. And after your first state, so now you have the second exchange phase. So the two systems exchange database description packets to find out your LSAs, that the link state address on the database of each system does not include. So what will happen for this reason? Each system stores LSAs that are not included in the link state database in the retransmission list. So for your loading phase, so we go now to the third phase. So each system sends link state request packets to request the neighbor or other system in this example. to send it to the entire LSAs that were stored in retransmission list during the exchange phase. The neighbor responds to the request with the LSAs or the link state address in the update packets. Then after it responds, so you are waiting for the neighbor to respond on this stage at loading phase. And when it's going to have the full phase, when two systems finish exchanging their LSAs and their link state addresses, uh, and their database are synchronized, agencies is established between two systems. So now you could be able to see the routers are already agreed and they are already synchronized. So in any case, you could have an easy communication. In summary, OSPF Hello protocol and the link state database exchange. So after the adjacencies are established between all the routers or system in an area. Each router or system in the area periodically send a link state address to share it adjacencies or to report its state change by comparing the established adjacencies with the LSAs, and the routers or system in the area can discover the area topology changes and update their link state databases accordingly. So that's how open short path first works. Now for the second, uh, we have also this method. So we have designated router and backup designated router. In cases of multi-access OSPF network that has at least two attached router, the routers elect a designated router and a backup designated router using the Hello protocol. So, multi-access network is a network in which multiple devices can connect and communicate simultaneously. The designated router generates LSAs for the entire multi-access network. It floods link state addresses to the routers in the network and determine which routers should become adjacent. All other routers in the network are adjacent to the designated router, and the designated router decreases the network traffic and the size of the link state database for the network. Now, for the designated router and backup designated router. So the backup designated router does not have any differences from other routers, except that it is needs to establish adjacencies with all the routers in the network. So including the designated router. The backup designated router is promoted to the designated router when the current designated router fails. So this is in this way, the network will be still present in cases the first router or the designated router fails. So that's the purpose of the backup designated router. So in figure 2, as you see, there is a broadcast network. So there's a broadcast network, and okay, so we have 9.7.85 subnet. It's a broadcast network. Therefore, routers in 9.7.85 subnet elect a designated router and backup designated router using Hello protocol. In this example, System A is elected as a designated router and System B is elected as a backup designated router. So you have system B as your backup and system A as your designated router. So a router that is located on the border of OSPF areas and connects this router to the backbone network is called the area border router. The area border router has multiple interfaces to multiple areas and maintains separate link state database for each area. So in this diagram, so on each router, we have the we router is connected to a different area. So example, this is area 1.1.1.1, and we have area 2. You have area 2.2.2.2.2. So every area has its own designated router. And so in this case, so every designated router or area border router establish a link state database and adjacency with each other so that they could be able to synchronize or be able to transfer information. Now we go to the second routing protocol. We have the enhanced interior gateway routing protocol. Is an interior gateway protocol that is suited for many different topologies and media. And in a well-designed network, enhanced interior gateway routing protocol scales well and provides extremely quick convergence times with the minimal network traffic. So enhanced interior gateway routing protocol uh, has some advantages. So very it's use very low usage of network resources during normal operation. It's only use hello packets that are transmitted on a stable network. When a change occurs, only routing table changes are propagated, not the entire routing table. This reduces the load the routing protocol itself places on the network. And also, we have the rapid convergent times for changes in the network topology. And also, EIGRP is an enhanced distance vector protocol relying on diffuse update algorithm or dual to calculate the shortest path to a designation within a network. So both are different routing protocols. So there are major revision of the protocol. So we have version 0 and version 1. So enhanced interior gateway routing protocol is used by Cisco most of the time. And in some in this paper does not apply to earlier version. So because we have this also made in this version that I copied, they have already include enhancement on performance and stability. What is the basic theory of enhanced interior gateway routing protocol? Is that a typical distant vector protocol saves the following information when computing the best path to the destination. The distance, the total metric or distance, such as hop count, and the vector of the next hop. For example, we have all the routers in the network in figure. This is figure 4. I haven't changed it. So are running in the routing information protocol. So the router 2 chooses the path uh, to network A and by examining the hop count through each active path. So after that, since the path through router 3 have 3 hops, so you have router 3, so you have 3 hops, and the path through router 1 has only have 2 hops. So you have two halves from routing one, and when uh, uh, the path one and discards the information it learned from the tree. If the path between router 1 and network A goes down, router 2 loses all connectivity with this destination until the times out the route of the routing table. So the router 3 re-advertises the route. Usually it occurs every 30 seconds. So it doesn't include the hold down time. It would take like 90 to 190 seconds for the router 2 to switch path from router 1 to router 3. So in this way, so it's either you're going to switch. So 1, 2, 3. So 1, 2, 3. So you switch to another path to access to network A. So if you want this, so you have three hub, but if this one you have only two hub going to network A. So E.I.G.P.E instead of counting on full periodic updates to reconverge, it builds a topology table from each of its neighbor advertisements. So that is the discarding of data and converges by either looking for a likely loop-free route in the topology table, or if it knows that no other route by querying its neighbors, the routers too saves the information it received from both routers 1 and 3. So it chooses the path through 1 and it's the best path, the successor, and the path through 3 as a loop-free path, a feasible successor. When the path through Route 1 becomes unavailable, the Route 2 examines the topology table and finding the feasible successor and begins using the path through 3 immediately. So from this brief explanation, it is apparent that EIGRP must provide a system where it sends only the updates needed at a given time. This is accomplished through neighbor discovery and maintenance. Also, a way of determining which paths a router has learned are loop-free. So a process to clear bad routes from the topology and tables of all routers on the network. So enhanced interior gateway routing protocol is a process for uh, querying neighbors to find the best path to lost destination. So you're going to ask the nearest path for you to be able to find the location of the destination that is not present. So in this way, how we have to address neighbor discovery and maintenance, which is important in enhanced interior gateway routing protocol. This is to distribute routing information throughout the network, uses non-periodic incremental routing updates. And the basic problem with sending only routing updates is that you may not know when the path through the neighboring router is no longer available. So because EIGRP relies on neighbor relationship to reliably propagate routing table routers become neighbors when they see each other hello packets on a common network. So you cannot time out routes expecting to receive a new routing changes from your neighbor. So also, EIGRP sends hello packets in every 5 seconds on a high bandwidth links and every 60 seconds on a low bandwidth multi-point links. Now for your uh, what are the messages that we are going to send for this is a low bandwidth and this is for the high bandwidth. So we apply it for broadcast media for Ethernet, token ring, and fiber distributed data internetwork. We also use 5-second hello in point-to-point serial links, such as this frame relay point-to-point. And we have also high bandwidth, so greater than T1 or multi-point circuits. We have also used 60 on the 60-second hello multi-point circuits of T1 bandwidth or slower. So T1 is like your communication medium or transmission one or your terminal one. So this is high speed internet, I think T1, and you're going to use ATM switch virtual circuits and ISDN. So if you don't know ATM, so please try to check your network one lecture. So what are the factors we are going to consider when deciding to use routing protocol or static routes? So first question that we're going to come in mind is, does the network change often? With the new networks being added or networks going offline frequently, so if a routing protocol is probably in good choice, if not, static route should be already be considered is enough, okay? And the second question is, are the several alternate paths to many of the networks in the internetwork? If yes, so a routing protocol can reroute around downlinks or congested routes automatically. But with static routes, an administrator must change the routing table manually after the problem is discovered. The last questions that we're going to ask is the internet network large with many networks and remote sites? If so, keeping up with the status of all the networks might prove to be more work than you bargained for if you're using static routes. Routing protocol builds and maintains routing tables automatically and freeing you to do more important tasks. So that's why we use a routing protocol because it allows you to get away with having to manually write each task on the routing table. So the last part we have of your after routing protocol, so we are going to consider the access control links in your router. One advantages of using routers in an internet network is that you can group users who needs access to common resources into subnets. A router facilitates users in one subnet being able to access resources on one another subnet. But it can also be used to block access. And also, routers use access control lists to determine which network traffic passes through and which traffic doesn't. So, an access control list is a set of rules configured on a router interface for specifying which addresses and which protocols can pass through the interface and to which destinations. When an access control list blocks a packet, it's called a packet filtering. ACL or the access control links are usually configured to filter traffic based on the following. So we have the inbound or the outbound traffic and the source address, the destination address, and also the protocol. So these are the access control links configuration. But we will not configure access control links. We only going to have some example of VLANs this time. In summary, routers are used to dividing large network into smaller broadcast domains, as well as used to create a complex internetwork so that lands in a large international corporation. Ospf protocol is one of the family of IP routing protocols that has an interior gateway protocol for the internet used to distribute IP routing information throughout a single autonomous system in an IP network. IEGRP is used on a router to share routes with other routers within the same autonomous system. Unlike other well-known routing protocols such as RIP, E, EIGRP only sends incremental updates. So this reduces the workload on the other router and the amount of data that needs to be transmitted. So this is the last slide. So thank you for listening. Any questions?
None, sir.
None, sir.
None, sir.
Okay, so since there are no questions, I'm going to stop the recording and we move to the second phase or laboratory. But these laboratories, it would not take a few more time. So I'll stop the recording. Is it okay? I'll have like a 5 minute break. I'll just grab a water. Okay.
Sige, sir.
Okay. And you also.